Okay, let's solve sample 30. From the figure shown, compute the following: the moment about AX, moment about AY axis, and number 3, the moment about AZ axis. So this is the figure. So let's solve this by the scalar approach first. So first, let's resolve the force into its components. Fx is positive, Fy is negative, going down, Fz is also positive. So Fx is magnitude of the force 135 times component of distance 8 divided by distance square root of 8 square plus negative 5 square plus 4 square. So Fx is equal to 105.4 newtons. Fy is, you just replace 8 by 5 going down. So Fy is equal to 65.87 newtons. Then Fz is 135 times 4 divided by distance square root of 8 square plus 5 square plus 4 square. So Fz is equal to 52.7 newtons. Then let's modify the figure. Let's magnify the figure. Then apply the components of force. These are the distances. So Fx is 105.4, Fy is downward 65.87, and Fz is 52.7 forward. So position your right thumb towards the positive x-axis, then core your four fingers. The positive moment should be in that direction. Ignore 1 Fx in computing for moment about Ax because it is parallel to the x-axis. Just consider Fz and Fy. So from the figure, the component of force that has the same sense of moment about the x-axis is Fy. Its moment arm is 3.8 because imagine this is x-axis, so that's 3.8. Then Fz is negative because it is opposite. Its moment is going in that direction. So imagine this is the x-axis, then Fz is going in that direction, so negative. So moment about Ax therefore is 65.87 times 3.8 minus 52.7 times moment arm 4.6. So 65.87 times 3.8 minus 52.7 times 4.6. Computing for Max is equal to 7.886 Newton meter, and the sense is positive, so its moment is in the same direction as this. Then for My, position your right thumb towards the positive y-axis, core your four fingers. That would be the direction of the curling of your four fingers. So that's the positive sense for moment about y-axis. So don't mind Fy, so just Fx and Fz. So obviously, Fx will have the same sense in that direction. Imagine this is the y-axis, so positive, and moment of Fz is negative because its sense is, if this is the y-axis, it is opposite to that sense. So 105. MAy is 105.4 times 3.8. Imagine that's the y, so this is the moment arm, minus 52.7, the moment arm is 8. So MAy is 105.4 times 3.8 minus 52.7 times 8. So computing for MAy, it is negative 21.08 Newton meter. And finally, moment about Z, position your right thumb towards the positive Z axis. The curling of your forefinger would be in that sense. So positive moment would be in that direction. So don't mind Fz, just Fx and Fy. So moment of Fx is, imagine it is coming from bottom. So its moment is the same sense as that. So it's positive. The moment arm is 4.6. So 105.4 times 4.6 positive. Then the moment of Fy is opposite. It's going down, then in that direction, opposite to that direction. So minus 65.87, the moment arm is 8. The distance of Fy and the z-axis is 8. So 105.4 times 4.6 minus 65.87 and times 8. So MAz is equal to negative 42.12 Newton meter. So these are the moments about X. moment about y, and moment about the z-axis. Then let's have the vector approach. So the force, these are the components of force. Components of, because moment about A is RA to B, point on the line of action of the force. So RAB cross the force. So ang RAB is to the right, 8. So 8I minus 4.6J, then plus 3.6 to reach P. So components of RAB would be 8, negative 4.6, then 3.8. So in matrix form, so 8, negative 4.6, 3.8, then x component of force, y component of force, which is negative because this is downward, and z component of force. Then components of unit vectors in the third row. Then copy the first two column elements. Then by basket method, let's begin with I. Let's check if these terms are in these terms here. So we have 52.7 times negative 4.6, or negative 52.7 times 4.6i, which is that negative. Then this is positive direction. This is positive direction, so that's why positive of 52.7 times negative 4.6 is negative. This is the negative direction, so negative of negative 65.87 times 3.8, that becomes positive. So there is 65.87 times 3.8, is positive. Therefore, the MAX, or the x component of moment about A, is the same as 7.886. Then for J, this is the positive direction. So 105.4 times 3.8 positive, which is this term here, minus that term 52.7 times 8. So we have minus 52.7 times 8. So it's the same. Then for K, we have negative 65.87 times 8, negative. This is this. Then minus this product, minus 105.4 times negative 4.6. So that would be negative 105.4, negative 4.6, that's positive. So 105.4 times 4.6, which is this term. This is the same as that. So therefore, the result would be 7.886I minus 21.08J, then minus 42.12 K Newton meter. So this is the MAX, this is MAY, and this is MAG.